Hey guys, so it's Stephanie Sarceno here, and I have the 2003 number 77 AP Calculus question. This topic is related to the integral as the area under the curve. So, you could use your calculator for this question, but I don't recommend you do so, or you don't actually need it. Yeah, let's start, I guess. So the question says, the regions A, B, and C in the figure above are bounded by the graph of the function f and the x-axis. If the area of each region is 2, what is the value of the integral of negative 3 to 3 f of x plus 1? Okay, since we know that the area under the curve is the definite integral of the curve, the area would be the sum of the integral, here, shown there. Okay, so what we know that when we see an integral with two functions on the inside, we could actually break that apart and it'll equal the same thing. So that's what we're gonna do. We're gonna break this integral. Okay, so hopefully you guys could see that. You could squint or put your glasses on or something. Okay, so I'm going to start off by finding the integral of f of x, and yeah. So this integral is actually asking for the area under the curve from negative 3 to 3. It's literally asking for the area there. And since we know that the area of each region is 2, we're going to go ahead and fill that in. So we know that this is 2, the area that here, B, is 2, and we also know that the area here is also 2. But because it's below the x-axis, it's actually going to be negative 2. So negative 2, and this is also negative 2. So when finding the area under that curve, we're going to add those all together. So negative 2 plus 2, negative 2. And we're all intelligent in here, so that's negative 2. Okay, we could do this part in two different ways. We could either, we know that the integral of 1 is actually x, so we could actually find x with its little boundaries. We could do that. And that will give us, so it's going to be 3 minus negative 3, and we know that's plus, and that gives us 6. But we could do that a different way. The way I did it is I visualized it. Oh wow, that's really bad. My bad. Oops. Okay, so what this is telling us is that at y equals 1 right here, it's asking for the area under here. So that is what this integral right here, that's what this is this. Okay, so we could just solve for the area of this rectangle. And we know this space right here is actually 6 because it goes from negative 3 to 3. That's the length of 6. And 6 times 1 is 6. So we could do that two different ways. So 6 here and 6 there. So now we're going to go back and add those two numbers. Negative 2 plus 6 gives us the magical number of 4, which is C. Excuse the baby if you could hear him. Okay, so when I first tried to answer this question, I automatically just counted up the areas of each region, and I was like 2 plus 2 plus 2, that's 6, and then plus 1, that's 7. But that is definitely not how you do it. So that is why it is not D. Yeah, well, in summation, I guess, we know that the integral as the sum, like right here, is always equal to the individual integrals added together, which is why we were able to break it up into two different ones. And when it asked for the integral of -3 to 3, we just added all the areas under the curve. And because the area under for A and C was below the x-axis, that is why we made it to -2, and we got a total of -2. And then solving for the integral of -3 to 3 of 1, we could either find it this way by doing this, getting a total of 6, or we could actually graph it to solve for the area right here and gives us 6. So -2 plus 6 is 4. And yeah. Okay, good luck on your AP Calculus test and stuff. Bye!